Hello and welcome to this video. In this video, we will study two more things about binary search. One is the traversal. There are three ways to traverse: pre-order, in-order, and post-order. And then we will also implement a tree which will be balanced. So we have lots of new routines. We have in-order, pre-order, post-order traversal. Then we have a height function. We have rebalance. And to rebalance, we implement rotate right, rotate left, double rotate right, double rotate left, single rotate right, single rotate left. So because of introduction of rebalancing, the old implementations are now changed. You will notice that there is a height attribute in the node. And then if you see our insertion routine, that has changed because let me find the insertion routine. Insert, yeah. So now if the root node is not null, then we rebalance the node. Okay, we rebalance in both the cases. That is one change. Okay, and then we have an ht function which turns the height of the node. In new node, we have computation of height of the node, and now we also have another function max, which compares two values and return maximum of those. The delete routine has changed. In the delete routine, we rebalance root again. Okay, if data is greater than root's data, and in case of left also we balance. If data is equal to root, then we don't have balance. But in case when both the sides are having children, both children are there, then we again rebalance it. Find is same. Now let's look at the rebalancing thing, how it rebalances. So it is quite complex to explain this algorithm. So what you should do is you should use pen and paper to figure out how the rebalance will work. So this is rebalance function. It computes the balance height of left and right tree. And if right height is greater than left height by more than one, then it does a rotate left, otherwise it does rotate right. In other cases, it does install height. So install height, if you see, it is not a different function. Let me find that. Install height. Okay, this one. So what it does is it recalculates the height of the root. Okay. Now let's go back to rebalance. So rebalance calls rotate left and rotate right. Now rotate right and rotate left are symmetric functions in their implementation. In rotate right, we take the left node of root and we compute the height of subtrees of left and right. And if the right one is greater than left, then we perform single rotate right, otherwise we perform double rotate right. So rotate left is similar. In this case, we take the right subtree and the height of left is jag and right is jig. So again, if jig is greater than jag, we perform single rotate left, otherwise we perform double rotate left. Double rotate right and double rotate left are similarly symmetric functions. In this double rotate right, we perform single rotate left and single rotate right on left node and root. And similarly, in double rotate left, we perform single rotate right on the right child and then single rotate left on root. Now, what single rotate left and single rotate left are single rotate left will do is they are also symmetric function. In single rotate right, we find out the left element of the root and we assign the right of left to the left, and then we perform install height. And then what we do is to the right node of L, we assign the root, and root is now new L. And finally, we perform install height. Similarly, single rotate left, we perform analogous functions. Now, the rebalancing is that way. So how it will actually work is You will have to use pen and paper to understand how this algorithm works. It's very difficult to show this using graphics in the code. Now we look at pre-order, post-order, and in-order traversal. In pre-order, we first print the data, then visit the left subtree, then right subtree. And in our order, we first visit left subtree, then we print the data, then we uh, go to right subtree. In the post order, we go to left first, then to right, and finally print the data. So one of the properties we should think about is that when you print a binary search tree in order, then it will always be sorted. That means the elements will come out in sorted nature. So let's see this in action. I will compile the program. So program is compiled. Now what I'm going to do is I'm going to insert a skewed tree. Okay. First 10, then 9, then I insert 8, and then I insert 7. So now what I will do is I'll perform a pre-order traversal. So if you think of pre-order traversal, we go to left node first. Okay. And pre-order, sorry, we print the pre-order, we print the element first, and then we visit the left subtree, and finally right. So in pre-order, if we traverse this tree, it should print 10 first, then 9, then 8, then 7. But let's see what happens. We perform pre-order traversal. It did not print 10, 9, 8, and 7, but it printed 10, 8, 7, and 9. That's because of the balancing of binary tree. It is not a skewed binary tree, but it is a balanced binary tree. And if you try in order, then it will give it in sorted order. And you can perform post-order traversal. 6, yeah. Post order is sorted as well. So that's all is there in this video. In the next video, we will do a level based ordering. Now there can be two implementation of level based ordering. One is using a queue and another is one without using the queue. Since the code would have been quite a lot to explain for, that's why I have skipped the level order traversal. We will see this in next video, that how to perform level order traversal using a binary tree. The only thing you need to grasp in this video carefully is how the rebalancing is happening. So you can look at the code in GitHub repository and check out that how it works. And I hope that you have found this video useful and informative. If so, please subscribe to the channel and like the video so that more people like you can go through the video and benefit from it. That's it in this video. I'll see you in the next video with the level order traversal. Thanks a lot for watching. Happy programming.